Welcome back, Fetchers of America. Come on over here, Kenny. Kenny, my main man, Batman here. Robin Rich, got my Hurley salmon-colored shirt on today to get you jacked, and a hat on too. We're all, and I don't even think I shaved. I mean, this is like pure BYU Idaho dressing grooming standards. We're ready to roll. Okay, so guys, the first part of today's lecture, we're going to do what we normally do in class and answer some of your questions. But since you're not here, I have some typical questions that are asked every semester. We're going to do a couple. So if you do need extra help with last night's homework, make sure that you check into the math lab. I just want to remind everybody that all of your math lab assignments are published. They are published in Canvas, and they're all due Saturday by midnight. But, you know, you got to get these codes from the math lab. Just one bit of clarity for all of you. We mentioned this a long time ago. The purpose is not to get codes and just give you busy work. The purpose is for you to get help. And to prove that you're getting help, if we were normally coming to campus and doing things on campus, you would take your iCard and swipe in at the math lab, and you'd get credit for going to the math lab. That's ultimately what we want. The codes are simply just to give you an opportunity to prove that you know what you're doing. And if you don't know what you're doing, you get extra help. Okay? So make sure you're doing that. Really, the spirit of the law is using the math lab to get questions answered and have 100% of your homework knowledge, solidified. Okay? So if you have any questions from 2.4 and 2.5, please jump in and get that taken care of. Let's do this first problem here. Big A equals A plus B plus C, all divided by 3. They're asking us to solve for B. This is one of the problems in the homework. You very well could have a problem just like this on the test. So definitely want to take some notes and watch this. This formula is the formula for average. Big A stands for average. Each of these is an entity. Maybe you took 3 tests in a class, test 1, test 2, test 3. We always divide the number of the entities by the number of entities. There's 1, 2, 3 of them, so we divide by 3. If we had an A plus B plus C plus D divided by 4, then if we had A plus B plus C plus D plus E, we would divide it by 5. These are just the standard average formula. So they want us to get little b alone. Again, I ask you, are big A's and little a's like terms? They're not. We talked about how uppercase and lowercase behave differently. So if the goal is to get b alone, first step in the 3-step process to solving. So again, let's all write our 3-step process to solving. Let's take a minute and pause at home and just write the 3-step process to solving. I will go ahead and pretend that you're pausing right now, but we're going to write this up here. We're going to come to the far right board, or far right side of the board here. And so when we solve, remember the goal is to get x alone, okay? And step number 1, we simplify. And so we're going to start doing a real shorthand version of this. And so FRACT, fractions, okay, parentheses, like terms and one side. Okay, so these are all your little prompts. We're going to take care of fractions, distribute parentheses. We're going to combine like terms. In taking care of fractions, we're going to get rid of them. Get all of our x's to one side. And then steps 2 and 3 are the AP and the MP, the addition principle and multiplication principle. There's a real quick shorthand way to write the 3-step process to solving. So we look right here. Do we have fractions? Yes, we do. What's the LCD? It's 3. It's the only D. So we're going to multiply 3 times big A and 3 times A plus B plus C all over 3. Now, I asked you the other day a question when we were doing another problem. I said, how many terms are on this side? This one gets a little confusing for people. Right now, this is one singular term. Students say, but Brother Rich, you taught us that terms are separated by plus and minus signs. True, true, true. But it's all over one denominator, therefore this acts as one term. Do you understand? We could say this is A over 3 plus B over 3 plus C over 3. This right here, we could say equals this. Now that's 1, 2, 3 individual terms. But when we take all of them and place them over one single denominator, that unites them as one term. So this is 3 terms, and this is 1 term. When it behaves as one term, then this only has to be multiplied by this one entity. If we wanted to multiply 3 times this side and 3 times this side, and we did this, we'd have to multiply 3 times this, 3 times this, and 3 times this. Then each of these 3's would cancel out. Okay? But in this instance, these 3's just cancel out, and we're left with A plus B plus C. Like here, we would be left with A plus B plus C. Okay? So I'm going to erase this. I know that was a little quick talk there, but that's what we do. We multiply each side by 3. The 3's cancel out. You get 3 big A equals A plus B plus C. Now, who is sharing sides with B? Nothing but little a and little c. Okay. So we could go through our thing. Or do we have parentheses? No. Like terms, meaning other b's running around? No. Are all our b's on one side? Yes. Addition principle. We're going to subtract a and subtract c. What we do to one side, we do to the other. We're going to subtract a, subtract c. We get 3 big A minus C equals little b. We're done. That problem is taken care of. That's a good problem. Okay. Next one. V equals 3k over t. V equals 3k over t. We have a lowercase t on there. We're going to use uppercase t because my lowercase t's look like plus signs. Do you have fractions? So this one posed a little bit of an issue for some of you because it was all variables. There was nothing numerical here. Yes, you do have a fraction. What is the LCD? The LCD is the variable t. It's the only variable, I mean, it's the only denominator, but instead of being a number, it's a variable. So we're going to multiply, if your LCD equals t, we're going to multiply t times v, and t times, again, this is just one term, times 3k over t. And these t's cancel, and you're left with tv equals 3k. Okay? The goal is to get t alone. Who's sharing sides with t? V is, okay? We don't have parentheses, we don't have like terms, meaning other t's running around. All our t's are to one side. Nothing's being added or subtracted, so we're going straight to the multiplication principle. V is being multiplied, so we're going to divide by v. What we do to one side, do to the other. We're going to divide this by v. These cancel, we get t equals 3k over v. These are two very typical questions that we see asked in regards to section 2.4. What about section 2.5? Let's go ahead and pause for just a second. All right, guys, back. So, you know, it's tough to say what students ask. A lot of times there's not a lot of questions in 2.5. Just put one on the board here, has a decimal in it, creates a little bit of a different scenario. I think the only ones that sometimes cause a little bit of problem are these percent ones, okay, just occasionally. Drop down translation, 0.8 is 0.8. Is means equals. 16%, remember, we must convert that to a decimal. So we have 0.16. Of means multiply. What number is x? Okay, we're going to divide this, Kenny, if you want to do this on your calculator, by 0.16 and divide this side by 0.16. Okay, these cancel out, and then what is 0.8 divided by 0.16, Kenny?
5.
It is 5, okay? 5 equals x. Sometimes we'll see some where they're asking for the percent. Ken, you want to find one in there where the percent is the unknown real quick? I'll erase this real quick.
What percent of 100?
And this is right? We got this right?
Yeah.
0.8. Okay.
Yeah.
You're solid.
Yeah.
Okay. All right, good. What percent? Go ahead.
What percent of 150 is 39?
What percent of 150 is 39? Okay, we talked about this. So the what percent becomes the variable. Remember, we're looking for a percent now. Of comes down. Of means multiply. 150, that just translates straight as it is. Is means equals. 39 is a number. It translates straight as it is. Who's sharing sides with x? 150. It's being multiplied. We will divide. So we'll divide both sides by 150. We get x equals, what's the decimal we get, Kenny?
0.26.
0.26, okay? And so on this, again, are there any other decimal points on that?
No.
Nope, just 0.26, all right. And so we're going to move this decimal 2 places to the right, call this 26% because they asked for a percent, okay? All right, so that wraps up all of our review of 2.4.2.5. Any other questions, make sure to get help at the math lab. We're going to jump into lecture now. Let's go ahead and pause for just a second. Okay, guys, so we are about to embark on one of the most challenging parts of math, and that is word problems. Some of you might be like, gosh, Brother Rich, why aren't we together today? Well, we're going to be together next week on Tuesday. Remember, Monday classes are now on Tuesday. Monday's a holiday. And we will go into depth into word problems, but I want to scratch the surface of word problems with you today. I'm going to do my best to make word problems easier for you to understand. I'm going to have Kenny put a word problem up on the screen for you right now, and I'm going to read with you. And I want you to read along with me, okay? So that picture of that sexy critter right there, that is the author of your textbook. His name is Marvin Bittinger. I've met Marvin. Anyways, if you're totally wanting that jumpsuit that he's wearing. I bet you could look in some 80s catalog and find that. All right. I'm going to read this problem with you. And I want you to pretend, well, just listen along to what I do, okay? We read this. The author of this text exercises regularly, okay, so let's all read along together, at a local YMCA that recently offered a body fat percentage test to its members. The device used measures the passage of a very low voltage of electricity through the body. The author's body fat percentage was found to be 16.5%, and he weighs 191 pounds. What part in pounds of his body weight is fat? Okay, Kenny, let's drop that for a second. So I want you to think about this. Let's pretend that I'm you, that I'm a student, and that I just read this problem, okay? So I read the problem, and as soon as I get done, typically students go, and then they start reading it again. Okay, go ahead and hold it up there again. And this time they read it, and they read it just a little bit faster. Like, the author of this text, like almost with a sense of frustration, exercises regularly at a local YMCA that recently offered a body fat percentage test to its members. The device used measures the passage of a very low voltage of electricity through the body. The author's body fat percentage was found to be 16.5%, and he weighs 191 pounds. What part in pounds of his body weight is fat? And they sit there and they go, and then they start reading it again. The author of this text exercises regularly. Okay, so who relates to this? Okay, most of us do. We relate to it because what we're trying to do is what we've been taught to do since we were little children. We read for comprehension. We read to understand. But this is math. We don't need to understand. We don't need to know anything about YMCA, low voltage electricity, how to measure body fat. We don't need to know anything about that process or any other process really that we have a word problem in. What we need is numbers. Math is all about numbers. So I'm going to teach you a process today called DVPE, okay? DVPE. Am I good on the boards here if I come to here?
Yes.
Yeah, D, V, P, and E. D stands for data. Everybody write with me, okay? We're going to read the problem one line at a time, okay? And we are going to extract all the numbers, okay? So we're reading to get numbers. So I'm going to reread this problem one more time with you. Kenny's going to hold it up one more time, but this time we're going to read it one line at a time. And instead of trying to understand, we're going to be looking for numbers. Go ahead, Kenny, hold it up there. Okay, so the first line, the author of this text exercises regularly at. Okay, that's all crap. It's just words. We don't need it. A local YMCA that recently offered a body fat percentage, junk. That's all junk. We don't, no numbers there. Test to its members. The device used measures the, so remember, I'm reading one line at a time, and I'm not finding any numbers, so that's just garbage right there. Passage of a very low voltage of electricity through the, okay, more crap, okay, moving on. Body, the author's body fat percentage was found to be, okay, more junk, okay, 16.5%. Ding, ding, ding. Okay, put her down. Okay, so here we are. This is problem number 49. We're going to write D, V, P, and E. This is how we're going to set up our homework. And we have 16.5%. Okay, so we're going to extract the numbers, and as we extract them, we're going to label them. Okay, so this was a percent, so we labeled it a percent. Let's go ahead and hold it up again. Okay, and it says the author's body fat percentage was found to be 16.5%, and he weighs 191 pounds. Ding, ding, ding. There's another number, okay? And we'll label it 191 pounds, okay? They have pound, we can say pounds, either one. All right? Moving on, okay? It says what part in pounds of his body weight is fat? All right, so we're done. We're done, okay? We have extracted all the numerical information. So it's a different approach. Rather than reading the problem to understand the problem, I want you to read the problem one line at a time and extract the numbers, okay? V. What does V stand for? V stands for variable. Okay? This part of the problem is where we define what X equals. Basically, define the unknown. Now, this is often the last sentence. And it's often posed as a question. Okay? So let's go ahead and hold that up one more time, Kenny. One last time. Okay, sorry, buddy. Kenny and I are tripping over each other here. Okay? It says, what part in pounds of his body weight is fat? Okay. So think about it. X equals pounds of fat. Now that's a sexy thought right there. Pounds of fat. Ooh, just this massive glob of fat. Okay, cool. We'll use it, spread it on the pan. Okay, heat up some bacon, whatever. All right, listen. Okay, P. P stands for plan. Some of you are like, P, I did that this morning. I get it. Okay, P stands for plan. This is the hard part. Okay, this is the hard part. this is the part where you are required to think. Okay? Now, I'm going to tell you, in this class, we're not going to leave you alone to think. Okay? So I'm going to raise the three-step process to solving here. I'm going to tell you that, in life and in math, and we'll talk about this more when we meet, we have to think. We have to use our minds and our hearts to make our decisions. And God knew this from the very beginning. And so in word problems, people are always like, hey, when am I ever going to use math in the real world? Well, we give you real world problems and you hate them because they're hard, okay? Because they require you to think. It's not just as simple as plugging things into a formula. So the plan is the hard part. It's where you have to think. And it's usually some kind of a formula that you have to come up with. Usually. Not always. Okay? A formula that you have to come up with. So we're going to draw a chart here. Okay? So we're going to learn, in this class, we're going to learn 6 different word problem types. The first type that we're learning about is what's called the percent problem. And we're going to give you something to memorize in the percent problem. So we have what we call the given, okay? And the given is going to be the plan. In this case, the plans. And the first one is what we call a standard percent problem. And the standard percent problem says we have some total number times a percent equals a part of that total number, okay? So the plan in this instance will be this formula, total number times a percent equals a part of that number. Now I want you to look up here. How many entities do you have in the data and variable combined? 1, 2, 3. Okay? How many entities in this equation? 1, 2, 3. Okay, so what does E stand for? E stands for equation. And the equation is when you plug the data and the variable into the plan to get an equation. Okay, so you plug D and V into P to get an equation that you can now use the 3-step process to solve. Okay? All right, so let's look at this for just a minute. Obviously, we're going to plug these 3 things into these 3 parts, but this requires some thinking. We don't want to just blindly, like a lot of times people are like, oh, the big number goes here. And sometimes that's the case. But sometimes the unknown is a bigger number that goes here. Okay? In this instance, the total number is the total pounds that, Mr. Bittinger weighs. And he weighs 191 pounds. Okay? So we have 191. And then the percent is obviously this percent here. But we always convert percent to a decimal to work with it. So 16.5, we're going to go 1, 2. This is going to be times 0.165. And it equals the part number, which is X, because the part of your body fat, part of your body weight that's fat, is not all of you. You're not all fat. You'd be one of those like Disney blobs, like, okay? Your body's composed of water and bone and, just all kinds of different things, but fat is just a portion of that. So 191 is the total, fat is the part of the body weight, and we do this. So we go ahead and we multiply these two, and we get, I think, 0.325 or something like that. Would that be right, Kenny?
Yeah, 0.315.
0.315 equals X, okay? Well, they were asking for, is that right?
Oh, actually 31.
31.5. Okay, no, my bad. We multiply, so we do get 31.5. Yep. And so we have 31.5 pounds of fat. Okay, so Marvin Bittinger is carrying around 31.5 pounds of fat. Now, this is the hardest problem in section 2.5. We have 2 parts of homework tonight, and you're going to see this in the published assignment. Some are in 2.5, some are in 2.6. We're going to go over both of these a couple of times here. So here's the deal. I want to finish making this chart with you that we're going to leave up here. So the percent problem, the first thing we have to do is we have to be able to identify how do we know something is a percent problem. Well, it either has the percent sign or the word percent. Okay? If it has either of those, and this has a percent sign, then it by default becomes a percent problem. And so there's this other empty space right here that we're going to save for a moment. So go ahead, we're going to pause, take notes on this, we'll be right back. Go ahead. Can they see that, or is it backwards to them?
Right now it seems like backward.
It seems backwards? Was it backwards when you held it up last time? So, we're going to do number 38 together now. I'd like you to read this problem. Hopefully that's coming in clear. It looks like it's a little blurry, Kenny. Just make sure that they can see it at home. If you can't see these problems as Kenny's holding these up, I do apologize. You can just look at them in your textbook. Let's look at number 38, and we're going to let you pause at home and try to do this, but we're going to jump right into it. So we want to read this problem one line at a time. At one point in a recent season, okay, there's nothing there of importance. Peyton Manning of the Indianapolis Colts had, more crap, more junk, nothing there, completed 357 passes. Okay, so let's drop that for just a second. So data, we have 357 passes completed. Now, if you don't understand American football, you don't need to. This isn't about, reading for comprehension. We're talking about this. It's about the math, okay? So Peyton Manning, he played football. Okay, he's retired now. So let's go ahead and put that back up there. This was 62.5% of his attempts, okay? So this equals 62.5% of his attempts, okay? All right. Now, the next line says, how many attempts did he make? Okay, let's go ahead and put that down. So, my variable x equals total attempts made. All right, so you're going to have a problem that's about Sammy Sosa, a baseball player. There's golf problems in here, different things like that. Here's the deal. If I'm playing football or any kind of sport where I throw a ball, and I throw the ball at you, and you catch it, that's one attempt. I attempted to throw you the ball, you caught it, that's a completion, okay? If I throw it to you, and I throw it over your head, and you miss it, that's an incompletion, but it still counts as an attempt. An attempt means a try. I try to throw a ball to you 100 times, and you catch it 62 times, then you have caught it 62% of the time, okay? 62 out of 100. Remember, percent means per 100. So what we're saying here is this guy, Peyton Manning, he threw a total number of passes, and out of that total number, he completed 357, and he completed 62.5%. So we know this is a percent problem because it has the percent sign. The hard part of every problem is the plan. We're told to memorize this by Brother Rich. We'll have total number times percent equals part number. But if you do this the way we did the fat problem, you'll take this number, 357, and put it here, and that's not thinking, okay? You've got to think. Real world problems, which are word problems, require us to think. I can't emphasize this step enough, okay? We must take the time to truly think about what we're doing here. We're given as much as we can, but now we can't just plug things in randomly. Is the total number represented by total attempts or the number of passes completed? That's right, total attempts. So this is x in this instance. We're writing the equation now. Times a percent, 62.5, convert that to a decimal, 1, 2, we have 0.625, equals the portion of all the passes he threw that was caught or completed is 357. See, 357 is a part number of the total number of passes made. Who's sharing sides with x? 0.625. What's it doing? It's being multiplied, so you're going to divide. Divide by 0.625, divide by 0.625. These two cancel out. X equals, we're going to take 357, divide that by 0.625. Kenny, tell us what we get.
571.2.
Yeah, it is weird. 571.2. So you're going to have some instances in your homework where this stuff happens. And you're going to see in the back of the book, they say about 571 attempts. Okay, about. What does about mean, right? It means that they rounded this, okay? And so he threw the ball 571 times, and his receivers caught it 357 of those times, which is 62.5% completion, okay? All right, so you're going to have a handful of problems in section 2.5 So we already did part of 2.5, but tonight in the rest of 2.5, you're going to have some problems where you've got to balance this out. We're going to pause for a second and talk about the problems in 2.6, okay? Okay guys, so today's lecture YouTube video, a little bit longer because we do need to take good care of you on these word problem things. We're going to try to wrap this up in the next 15-20 minutes, but we want to make sure you're really well taken care of. So you'll notice here in this chart that there's this empty space right here, and basically there's two types of percent problems. We need to discuss the second type. So we've been discussing the standard percent problem, which basically always sets up where you have some total amount times a percent equals a part of that amount. Sometimes you're given the total and the percent, sometimes you're given the total and the part, you got to find the percent, sometimes you're given the part and the percent, you got to find the total, but you're going to be given two of those, and one of them will be the unknown that you solve for. And that constitutes the problems that you're doing in section 2.5. But then there's some problems in 2.6. And so we're going to have to learn how to differentiate between a standard percent problem and this other type we're about to reveal to you. So Drake Hill is one of our students, and obviously he's not in both your classes, but Drake's a good dude. So Drake, if you're out there, we're giving you a shout out. This problem's about you. So I figured Drake's a cool guy, and Drake wants to buy a Jeep. And he went and did some summer sales. He's feeling all kinds of cool inside. He makes a ton of money in the summer. And he comes home and he wants to buy like a Jeep, Wrangler, but he's gonna soup it up, jack up the tires, put oversized tires on, light bar, roll bar, all kinds of fun stuff. He's gonna have the convertible kit on it, all this stuff. Buys it brand spanking new, but his buddy owns the Jeep dealership and gives him a 30% discount off of sticker price. So it says here, Drake buys a Jeep. He pays $46,550 at a discount of 30%. What was the cost of the Jeep before the discount? Okay, so here's the deal. I'm going to have you pause for just a second, and I want you to try to do this problem based on what you know here, okay? So we're going to pretend pause. You go ahead and pause, and then we'll come back. We're back. Okay, so hopefully you wrestled with this. Well, here's the deal. This problem doesn't work out quite as well because if you think about it, most of you took the total amount, which you consider to be $46,550, and you multiplied it times a percent, which would be 0.30, and you wanted that to equal some part number. But here's the deal. If you're thinking, right, we just keep emphasizing this thing about thinking, okay? And I just can't say this enough, that word problems demand we use our brains, okay? And we don't need to be super intelligent, but we just got to understand common sense, okay? This price right here is already discounted. So what are we doing when we're multiplying it by 0.3? We're discounting it again? And then what are we going to get? A certain amount and then subtract that amount from this or add it back to it? I mean, it just doesn't make sense if you really pause and think about it. I mean, so here's the deal. There is a new formula, and this is a problem that we call the work backward percent problem. And the work backward percent problem says that we have some original amount plus or minus a change to that amount will equal a brand new total. Okay? Can we see all that on there?
We're good.
We're good? Okay. Now, one thing I want you to understand about the change, I'm going to put this in a different colored pen here. The change is always going to be a percent of means times the original amount. Okay? It's going to be a percent times the original amount. So we'll put times there if you can see that. It's kind of weird. And we'll talk about how we identify this against other types of problems, but these are the ones in 2.6. So if we take this problem and we do the same thing we did with DVPE, our data is that we have $46,550 is what Drake paid for the Jeep. It was a 30% discount, okay? The variable X equals the original sticker price or the original, price of the Jeep prior to the sale, okay? Prior to the discount, okay? So this is what the Jeep cost. So is this going to be more or less than? Let's use our minds. Is this going to be more or less than $46,550? Yeah, it's going to be more because the original price was discounted, right? So this is the discounted price. This is the price before the discount. So this is going to be more. Our plan, we cannot use this formula. We have to use this one. So we have to memorize two formulas. Our plan is going to be this original, not crispy, amount plus or minus a change to that amount equals this brand new total. Okay? So what's our original amount? That's right, it's X. Okay, this is the original price of the Jeep. Are we adding? Again, we have to think, are we adding or subtracting? When we say plus or minus, we have to make a choice. Are we adding or subtracting from the original price? Okay? Sometimes I get students say add. I think they're thinking, you know, like, oh yeah, we got to add to this. Yeah, you got to add to this, but that's not what this is. The original amount is X. We're going to subtract a discount, right? So basically we have the Jeep minus the discount, okay, equals the new cost of the Jeep, which the new cost is what he paid. So the change is a percent, and it's 0.30. Now, sometimes students will leave this here, and this one always kind of blows my mind because it's like, all you're doing here is subtracting 30 cents from the cost of the Jeep. It's 0.30 times the original cost. I want you to get this again. This will always be a percent times the original amount. And it equals the new total of $46,550. Well, let's think about this. We have 1x minus 0.3x makes 0.70x equals 46,550. Before we move on and finish this problem, which you can see what we need to do here, I want to ask you this common sense question. Did Drake pay 100% of the cost of the Jeep? No, he did not. What percent did he pay? 100 minus 30 makes 70. 70% converted to a decimal is 0.70. What I just did out loud is what we did here. We took 100% of the cost of the Jeep minus 30%. We had this discussion recently when we talked about, you know, when we purchase things, and we're going to get into that. Sales tax. We rarely pay 100% of anything. We usually pay a little more or less depending on what's going on. So who's sharing sides with X? 0.70. We're going to divide because it's being multiplied. What we do to one side, we do to the other. And so we get 46,550 divided by 0.70. Go ahead. What is that?
$66,500.
$66,500 is how much this Jeep cost before the discount. Okay? That's awesome. All right? So if you did it the other way where you started messing with this, and I want you to wrestle with this, you got some other amounts that could come close to this but never achieved this. So how do we tell if a problem, okay, so we're just going to add a little something here. I'm going to put right here, identifier. So our identifier for a percent problem in general is just percent or the word percent. But the identifier for a work backward is that we have words like pre, before, original, regular. But basically, the story is telling you that we know the price that we're paying, or we know the amount that we are dealing with now, but we don't know what it was prior to the change that was made. And so we have some change being made, okay, to our number. And that's the case here, okay? Let's go ahead and pause. We're going to do one more example. All right, so Chandler, the other day, we were talking about it. He was making fun of Brother Rich before class, and so we're gonna give it back to Chandler today. So Chandler, you chump, you paid $85, including a tip for a meal. That's a lot of money for a young man like yourself. You know, you go out with your lady love or your significant other, and you go out and you get some really nice meals, steak, lobster, something like that. I mean, you know, with drinks, and I'm not saying like alcoholic drinks, even just like, you know, virgin strawberry daiquiris, pina coladas, something like that. I mean, you could spend $85 easily at nicer restaurants for nicer meals and stuff. So it's Valentine's Day. Chandler is feeling the love, and he is taking his lady love out to dinner, and they go for big. Chandler, he's trying to prove that he's worth it for this young lady, and so he takes her out, spends a lot of money, gives a 20% tip. So Chandler paid $85, including a tip for a meal. He tipped 20%. What was cost of meal pre-tip? So my question to you guys, is this a standard problem or a work backward problem? Well, we see one of our magic words here, okay? We see the word pre, okay? We see the word pre right here. And if we think about the story itself, we know what he paid, but what we don't know is what he paid prior. We know what he paid total, but what we don't know is what the cost of the meal was. So we got to work backward in time. So we have to use our DVPE. So let's go ahead. We have D is $85, okay, and that was the total cost of the meal. Total cost, including the tip. He gave a 20% tip. Our V for variable is that X equals the original cost of the meal. Okay, so prior to the tip. P stands for plan, and we're going to have original amount plus or minus a change to that amount equals a new total. Now I want to ask you guys this really quick because we're running out of time. Okay, the next class is coming in. They want some action, okay? Did Chandler pay 100% of the cost of the meal? I get people all the time saying, yes, he did. Okay, listen, 100 means just 100. It doesn't mean any more than that. Did he just pay 100% of the cost of the meal? No, he did not. He paid 120% of the cost of the meal because he paid for the meal plus a 20% tip. Okay, so let's think about this. What was the cost of the meal originally? That is the part we don't know. That is X. Remember, we have three things here and three things here, so we got X. Are we adding or subtracting to the cost of the meal? We're adding. Think about it. It's meal plus a tip equals your total cost. Okay? So we're adding a tip. What is the tip? It's 20%. So sometimes students get silly and they say, oh, 0.20. That would just be 20 cents. Remember, we always take the percent of something. Percent times original amount. The original amount is X. And this equals the new total, and that's what he paid, of $85, the total cost that he paid. Again, if Chandler didn't pay 100%, he paid 120%. What's 120% converted to a decimal? It's 1.2 or 1.20. We think about this, 1x plus 0.20 is 1.20x equals 85. We divide this by 1.20, we divide this by 1.20. What do we get? Go ahead. $70.83. Is that right?
Yeah.
Yeah, awesome. So the cost of the meal prior to the tip was $70.83. All right, guys, here's the deal. Your homework that will be published is to do 2.5, 35 through 49 odd. These will be standard problems, standard percent problems. They'll all be percent problems tonight. And then you have 1, 2, 3, 4, 5 problems to do in section 2.6. Please pay attention. Do not do the other problems around these, the other odds. We got to teach you how to do those, and we want to spend some time on that. These will be work backward problems, okay? But what I want you to understand is the way the textbook is set up, every even problem that is the consecutive problem after the odds, so 18, 20, 28, 30, 34, those are the evens that go with those odds. You could do those for triple the bonus points, okay? And the reason I'll give you triple the bonus points is because the more word problems you do, the better you get at them. And they're hard to do. They take more time. So I'm going to give you triple bonus points. And I really encourage you to do these extra problems. And you can do the evens in this. So any evens that you do in this assignment, we're going triple the bonus points. Please alert the graders at the top of your assignments you take pictures of if you did any extras and tell them which ones they are. So like if you did 28, 30, and 34, say, I did 28, 30, and 34. Please give me extra credit. All right, you guys have a great long weekend, and good luck with this. You're going to need some help. You're going to need to work with tutors and go to the math lab as we work through these word problems. Good luck. We'll see you next time.